everybody. Welcome to the beginning of lesson 5 for this week. So this is the lesson that we're going through on Monday. At this point, I assume that you have already opened the PDF and that you are all looking at these problems. I imagine some of you have already maybe started making notes and answering some of these problems, and I know some of you are probably just following along with me. Both of those situations are totally okay. As long as you feel like you are getting as much out of this as you can, you're doing the right thing. So the way this is going to work is the way that it's worked every week so far. I will set up the problems, and then I will tell you to pause and handle these problems on your own. And then you can unpause and see kind of what I do about it or what I say about it. I might not answer or do every single problem. Some of them might be left up for you to solve or to think about on your own. If you have any questions about this lesson, please feel free to email me, to text me, to write me comments in Google Classroom, and I will respond to you as fast as I can. All right. With that said, let's start jumping into this problem. So this is lesson 5, building quadratic functions to describe situations. So remembering from last week, quadratic functions are anything that uses x squared. So just from the title, I'm already thinking about where are we going to be thinking about squared things, squared terms. And the two lesson goals for this lesson are, 1, I can use tables, graphs, and equations to represent the height of a falling object. And 2, I can explain the meaning of the terms in a quadratic expression that represents the height of a falling object. So just from these learning goals, I know that we're going to be looking at tables, I know that we're going to be looking at graphs, and I know that we're going to be looking at equations. And I know that this lesson is going to be all about falling objects. So let's jump right into problem number 1, 5.1. Notice and wonder, an interesting numerical pattern. Study the table. What do you notice? What do you wonder? So go ahead and take a few notes, write down a few things you notice and you wonder, pause the video, and then when you come back, I'll tell you what I notice and what I wonder. Okay, go ahead and pause the video now. And welcome back. So when you look at this table, you might have noticed a lot of things. You might have wondered a lot of things as well. Here's a few things that I would notice, almost kind of the first things I would notice. So one thing I might notice is the x values increase by 1 each time. And the x values start at 0. Right? So this is just me saying there's a table here, there's some x values, they start at 0, and they increase by 1 each time. And if you want to be more specific, by +1 each time. Yeah. The y values, though, still increase, but they increase by a different amount each time. And then maybe you said something like that as well. So I'm looking at this, the jump from 0 to 16 is +16. But the jump from 16 to 64 is more, right? It's actually +48. And then it just keeps getting bigger and bigger and bigger from there. You might have noticed or said other things about the y values. So you could have noticed or said something like the y values are all perfect squares. Now you would only notice this if you kind of already know some details about perfect squares, but what I mean is that 16 is 4 squared, and I'll write this down in kind of a thought bubble here. Maybe you didn't write all of this down, but here's some things that you might be thinking. Right? I know that 16 is 4 squared. I know that 64 is 8 squared. I know that 144 is 12 squared. And I do this for a living, so I know a few squares that are higher than average, but if you just notice these, that would be good. And so maybe you're wondering, right, is 256 a perfect square as well? And it turns out it is. 256 is 16 squared. And 400 is also a perfect square. It's 20 squared. So maybe these are things you noticed. Maybe these were things you were wondering. But these are all things that kind of show up in the table. Some questions that I have. What is the next y value? Right? Is there a pattern that I can leverage? Maybe can I find the next y value? And maybe that's another thing I wonder. Maybe what's the pattern or what's the formula? Pattern or formula? And if you're listening, you know what kind of person I am, because I'm not asking, is there a pattern or is there a formula? I kind of assume there is one. I just want to know what it is, right? I don't think this is a table of random numbers. I think there's a pattern, but I don't know the formula yet. You might have noticed and wondered additional things, and if you did, that's awesome. Don't spend all day writing down every single thing you notice and wonder, but just hit the highlights. Just a few comments. I'm not wasting time saying, like, I noticed that there are numbers here. Notice I'm saying what kind of numbers they are, right? Perfect squares, increasing by 1, starting at 0. I'm not saying things like, I noticed there's no z's, right? If you want to say, I noticed there's x's and y's, that's good. But see if you can start making those noticings a bit more detailed than just like, there's a table, there's a box, there's numbers, right? More detail is more helpful. It helps you pay attention to what's going on in the problem. But that's 5.1. Tune in to the next video to move on to 5.2, and I'll see you there.